This is lesson for 5.8, Solving Systems of Inequalities. So we're going to be graphing the boundaries for each inequality in the system. We've done graphing inequalities in section 4.5 in Apex, and so you might want to review 4.5. We're going to be graphing a lot for this one section as well. The idea for the system is you're going to shade the region that contains the solutions valid for all inequalities in the system, which means where the shaded regions overlap. So when you're graphing an inequality, you're going to have shaded regions. When you have a system, you're going to have more than one shaded region, and we're interested where the shading overlaps. So here's an inequality. Let's just review graphing this inequality, make sure we recognize, this is a less than symbol. This is a little bit challenging because it's not written in the line form that we like, which is mx plus b. So let's subtract 2x from both sides. And that's going to rewrite our equation where I've got y, we've got the less than or below symbol, and then here's the line, negative 2x plus 3. To graph that, we're going to find the point positive 3 on the y-axis and put a dot there. And then we have the slope, negative 2, which means go down 2 and over 1. So I went down 2 and over 1, and I'm going to put another dot. And then I'm going to put another, I'm going to go down 2 and over 1. And I could do this over and over, but the main thing is I'm going to connect those dots with a dashed line because this is less than but not equal to. So we're going to end up with a dashed line. Now my graph looks like dots, but really it's dashes. So the dashes meaning not equal to this line. And this says shade below. So we're going to shade below that line, which is this whole area here. We're saying the y's are below this line. So this is graphing an inequality, but we're here to graph systems, which means we need at least one more equation, and we're always doing two. So I'm going to have a second inequality, and there it is. And once again, I want this y equals, start with a y, and I can see that has y and then the greater 2 symbol on this side. If we read it from the left to the right, it looks like a less than, but I'm reading with regards to the y. This is y greater than. And we're going to subtract 3 from both sides. When we're all done, this is what we get. Y is greater than x, and then we subtracted the 3 from both sides. So look at this, pause if you need to see how this equation turned into this one. I want you to critically reason through how that happened. Now we're going to graph it. And so we're going to graph this line x minus 3, which means to put a dot at negative 3. There we have it. And it says a slope of 1, which means go down 1 and over. Actually, it's positive 1. So go up 1 and over 1, up 1, and then connect. Again, we're connecting with a dashed line because this is less than but not greater than but not equal to. And since it's greater than, we're shading up above the line, and that's where y is greater than or above this line. Now you can see that we have this green shaded region from the first equation. We have the purple shaded region from the second equation, and this area here is where they overlap. Well, we need to erase the other regions. So we're going to erase all of that where they don't overlap. And when we're done erasing everywhere that they don't overlap, we can shade it in a lot darker and say, aha, this is where all the solutions lie. Any point in here makes this statement true, this system true. Because it means both of these statements will be true. Any point that's in this dark purple region. Let's do another one. Here are two equations. The second one we can see is already y and then the inequality symbol. But the other one says, no, it's on this side. So we're going to rewrite it. I want to write it the other direction. So I just changed this. This is y, and then the less than is pointing to the y. So less than x plus 3. So here I wrote it that way so we can see it better. And now you can see, y is going to be below this line. So we're going to graph the line, which means we're going to go to positive 3. The slope is up 1 over 1. And we're going to use a dashed line because it's not equal to. And this says shade below the line. And don't include the line, so the line is dashed. So so we shaded below it. This other one says we're going to be going above the line and it's going to be equal to, so we're going to use a solid line. We go to -1 and put a dot. The slope is 2, so we're going to go up 2 and over 1, up 2 and over 1, and I'm going to connect those with a solid line. And again, this says shade above, so I'm going to shade above that green. And again, this is a solid line because it's got the equal to. This is a dashed line because it doesn't have it. So now we're going to look at where it overlaps. Well, it overlaps right here. So we're going to erase all of that purple. And we're going to erase all of the green. Kind of erased my equation a little bit there, but we still have the equation sitting here. And I made it darker. And there's the equation back again. So now this is the solution. This shaded in region is the solution to the system. It means anything that lies in this shaded region will be true. So the next part of this is then I'm going to give you some points and we're going to determine whether or not they are solutions. So here are your points. And we need to look at these points and say, where do they lie? Do they lie in the shaded region or not? And we're also going to talk about the lines themselves. So the first point, 1, 3. Well, there it is. I went over 1 and up 3, and it's in the green shaded region, so that is true. Meaning, yes, it's a solution. It would give me a true statement to both inequalities if it's in here. The next point is 3, 1, so we're going to go over 3 and up 1, and there's the point. It's not in the shaded region, so no, that's false. It's not a solution to the system. -3, 5, we're going to go over to -3 and down 5. Oh, excuse me, it's +5. So over 3 and then up 5 because -3, +5. And this is not in the shaded region. So no, it's not a solution. 3, +5, we go over to 3 and up 5. And where is that? Well, if you look very carefully, it's right on the line. But this line is a solid line, which means anything on this line is also true. So this is part of the solutions to the system. But what about 3, 6? Well, 3, 6, we're going to go up one more up here, and it's on the dashed line. And the dashed line says that's false. Anything on that line is not a solution to this one equation. This equation, it's this equation right here. It's not a solution to this equation. It has to be a solution to both equations to be a solution for the system. So the answer is no, it is not a solution to the system. Here's our last example. I've got these two lines. They're just graphs, and I want us to examine the fact I've got a point right here. So I'll give you the coordinates for those points. Now you've got the coordinates. Well, we need to determine what's going on here and write the equation for these two lines. So I'm checking the slope, and I notice I go down 5 and over 7 by counting the squares on my grid, or you can use the coordinate points. And I'm saying, oh, that's a -5 over 7 slope. -5/7 is the slope. Well, this other line has the exact same slope. It goes down 5 and over 7. So that means this is a graph of parallel lines. Well, now let's look at the equations for those, or I should say the inequalities, because we're going to do some shading. So for this line over here, here is the line -5/7 x plus 8. And this says shade above the line. Over here, it's saying y is less than or equal to, so we're going to shade below this other line. When we shade, we have this, which is quite pretty. It looks kind of like a flag almost. But the main thing is I've got only purple over here, and I've got only green here. I have no common shading. They never overlap. And so the answer to this, meaning where's the solution, is there is no solution. If they don't share any common solution points, then there's no solution to the system of inequalities. And this would be an example of no solution at all.